So all of organic life is made up of carbon, and carbon is extremely versatile. Carbon is really cool. So carbon has 4 out of 8 valence electrons in its outer shell, which means that it has the potential to form 4 covalent bonds. That's the most covalent bonds that any element can form. And so carbon is used in backbones, really long chains. So carbon can form these really long chains of carbon with lots of hydrogens, and they can be straight. It can form these chains that have branches coming off of it, and then it even has the ability to form in ring-like structures. And if you remember back to the themes, structure implies function. All right, so if we change the structure, we change how it functions, right? So all of these 3 different molecules, straight, branched, and ring, are going to function differently. So we have kind of an infinite set of carbon structures that we can make just out of the carbon backbones. But we have other atoms besides carbon involved in our molecules as well. Things like oxygen and hydrogen and nitrogen and phosphorus are the most common. And what can happen is we can form these functional groups. So functional groups are kind of common groups that we see often on molecules. And when you add these to carbon backbones, they're going to change the structure and change the function again. I don't need you to memorize the functional groups. So we have the 5 kind of most common functional groups over here. OH is a hydroxyl group. We have CH3, that's a methane group. COOH is a carboxyl group. NH2, we've got amino, and this is a phosphate group. I don't need you to memorize the names, but you do need to know what a functional group is, and that by being added to a molecule, it's going to change the shape, which is going to change the function. All right, so when we build and we break molecules, we have to do a chemical reaction. So let's look at these words, monomer and polymer. The word mono means 1, right? Mono is singular. Mer, right here, this kind of suffix, is kind of a repeatable subunit. So in this case, we've just got ovals. That's what we're going to repeat. Poly means many, right? So monomer is going to mean 1 subunit, and polymer is going to mean many subunits. So we make polymers up of monomers. If I take monomers and I stick them together, I could end up with a really long chain of molecules, and that's called a polymer. All right, so we have to be able to build and break these molecules, right? So we have 2 reactions here that are super important. Dehydration, synthesis. So let's think about this word. What is hydration? What do you think of when you hear the word hydration? Hopefully you said water, right? So dehydration is when you don't have water. So if you're dehydrated, you don't have enough water, or you lost water. Synthesis means building or coming together, right? Synthesizing something is when you make something. So a dehydration synthesis reaction is when you're going to take away water to make something. So dehydration synthesis is right here. We have monomer 1 here in blue and monomer 2 here in orange. Look, here's some functional groups that are sticking off the ends of these monomers. So to join these 2 together, right, I want to make a bond here to join these 2 together. We're going to take a hydrogen from one and an OH from another, and we're going to pull those out. And that allows us to form this bond to make this dimer. Di means 2. If we add another one, there's 3. Can add another one, that's 4. Add a whole bunch, and then you end up with a polymer. Here's the water molecule. So the H and the OH results in a water, and that's been removed. So that's why it's called dehydration. We removed a water. Synthesis. We built this more complex structure. The opposite of dehydration synthesis is hydrolysis. So let's look at this word, hydro. Hopefully you're associating this with water again, right? Hydro means water. This suffix here, lysis, this is a word we're going to see in the next chapters as well. Lysis means to break. All right, so lysis means to break apart. So hydrolysis we're going to see in this reaction down here. Here's my dimer, right? We've got two molecules that are stuck together with this bond, and I want to break them apart. And I'm going to break them apart by adding water in. That water molecule is now separated back to where it was originally, and I've broken those two molecules into two separate monomers. Take a moment and reflect on the processes of dehydration synthesis and hydrolysis and how they are different.